Okay, so as I just mentioned, we have to really start exploring the game art pipeline very directly. And one of the things that I find is really kind of helpful as we begin to explore the game art pipeline is to ask a whole series of very direct questions on how we're going to use the assets that we're going to create. As I just mentioned, you know, in the big scheme of things, if we're keeping all of our stuff, if you will, in Maya or in Cinema 4D or in Modo, it really doesn't matter, right? Some of these details. It just has to work within the renderer in that app, okay? But for us in the game art pipeline, we have a critical question that we need to ask ourselves before we even start, okay? Does anyone want to take a guess as to what that question is? It's simple. Where is this going to be rendered? Okay? That's the question that you have to ask. How or where is this art asset going to be rendered? Okay? For us, game art pipeline, that's usually going to be a real-time rendering application, a game engine, like Unity. For us, we're going to be using Unity in here, or the Unreal game engine. Okay? And to get to that renderer, there's a huge sequence that we have to follow. Today, I want to focus on the modeling side. This sequence is going to continue to expand as we kind of advance through a whole series of stages. And I forgot to put this in the thing. So let me just kind of very quickly write this on the board. Okay. So there are some basic stages that we need to understand. Okay. Because now that we're leaving a single app and going into a multi-app universe, okay, we're going into the Spider-Verse. Did you guys see that movie? So good, right? So good, Into the Spider-Verse? Okay, cool. So there's some really big stages that we're going to go through, okay? We're going to focus today on kind of the first stage, which in every sense is just the conceptualization stage, right? Just understanding the concept, okay, of what it is that we're building, okay? Now, once we're done with the concept stage, we then have to go into the geometry creation stage. So we have to create the model, and I'll just put model with an emphasis on the geometry. Okay. Once the geometry is created, we then have to create a very critical, extraordinarily technical piece of data called UV maps. Okay. What UV maps allow us to do is to create textures. Okay. Think of the UV maps as the pattern to address, okay? We almost have to kind of reverse engineer our models. If you think of a garment manufacturer, they're often going to start, a piece of clothing is just flat, right? Fabric is just flat, it's two-dimensional, but when we start to sew it in a very specific way, it then turns into a three-dimensional garment, right? We're kind of doing the exact same thing in reverse, right? We are starting with a three-dimensional object, but then in order for us to paint on it, okay, we have to create UV maps, which is a 2D representation of our 3D model. Okay? We basically need to flatten everything out into the 2D world, okay? So that we can bring it over in Substance Painter or Mari or even to Photoshop if we'd like, and custom paint texture information on top of our model itself, okay? This is the most uncreative part of our game art pipeline, okay, of the stages that we have to go through. It is going to be a mind trip when we get there, okay, because I'm going to fundamentally ask you to think differently, but it's critical. Because what that allows us to do is the texture, okay? Now, for a long, long time, for the game art pipeline, we used to emphasize just kind of the texture stage. We really didn't care so much about the geometry. The geometry just kind of had to work. The textures was really where all that information kind of resided, okay? But now, it's really a combination of all of these three things. Our tool set and our pipeline has matured and has become incredibly sophisticated that we really have to put an equal emphasis on all three of these to get the results that we're after, okay? And then finally, down here, I'm going to put render, okay? Now, if you are trying to get something to move, there's a couple extra sequential steps in here. But for us, this is what we're going to be going through in this class. Okay? We're going to be coming up with the concept. We're going to be making the model of the concept. But then we're going to make the UV maps of the models, the textures for the model, and then we're going to render it. Okay? And this is all going to be seen through the lens of real-time rendering, which is another big difference for us. Okay? As we begin to go into this pipeline, we have to be thinking at every single step of the way that we are making real-time renderable assets. Okay? How we used to do it inside of the Arnold rendering engine or Moto, that's specific to the television and feature film world. The real-time rendering folks require a couple extra elements to be created, and we're going to be making those today. Okay? Or in this class, not today, but in this class. All right. So a couple things to think about as we start to advance into the concept stage. This concept stage really has to be broken down into a couple different like subcategories, if you will. Okay. So we have the concept. This is some of you guys saw me working on this dinosaur last semester. We have the concept of the model. Okay. We have the prototype, which is kind of rough, kind of near perfect, mid-quality approximation of the model. And then we actually have the production asset that's got everything that we need. Okay? So each one of these has a whole series of questions that we need to get answers for. Okay? And I'm going to kind of provide you with some of those questions and answers just to kind of start to frame this a little bit. So when you start to go into the concept stage of your model, we have to ask ourselves, what is it that we're trying to do? And 9 times out of 10, when you're just kind of figuring out what this thing looks like, we're just exploring. We're exploring the shape and the form of whatever it is that we're trying to create. We are not underscore highlights, put a circle on it, a star, trying to create final models at the concept stage. Okay, everyone has an idea of what a dinosaur looks like in 2D, but that idea radically changes once we're asked to make a 3D model of it. The concept stage allows us the freedom to experiment, to try things out, to explore shape and form and proportion, which are critical to creating a sculpture. Okay? I kind of like to consider that what we are doing in this moment is actually creating a piece of digital sculpture. Okay? We're not trying to make it animate. We're not trying to make UVs. It's as if we're sitting there with a gigantic hunk of marble and we're just chipping away, trying to find Michelangelo or trying to find the David inside of the marble. Okay? If we come at it from that perspective, this part of the entire process becomes a whole lot of fun. This is where the true creation happens. Okay? The genesis of our idea grows and grows and grows and grows in front of us. Okay? Because we're just trying to throw something down, right? Just trying to create something. We don't care about geometry. We don't care how much geometry, what it looks like. So it can all be tessellated. It can all be triangles. It does not matter. And I realize now that I see this on the big screen that if you look very careful at my Ankylosaurus over here, man, it is all triangulated geometry. This is unriggable, untexturable. You can't do anything with this model except look at it. Okay? It is purely a piece of sculpture. That's all it's designed to do. Okay? So if you're just trying to create a concept model, we don't care what it looks like as far as the technical back end of the model goes because it's just geometry. Okay? We don't need to have UV maps on it. We're just going to maybe, just admire it and say, yep, this is it, right? This is the direction that we're going. We want to keep it really loose as far as the technical requirements of our asset and during the concept stage, during the, while we're figuring it out. We don't want to have to, once we start marrying ourselves to topology, and once we start marrying ourselves to UV maps and textures, our creative freedom begins to shrink very directly, okay? At this stage, this is like the most free part of our production pipeline, right? We're just trying to create something. Doesn't matter how it works. Once that creation, once you kind of zero in on what the form and the volume and what the shape is going to look like, then we have to actually start getting serious about it, okay? Now we need to start throwing this into the prototype stage where we do care about the geometry and we do care about how all of these polygons are working together to create a digital representation of our sculpture. Okay, so we need to create sculptable geometry, which equals all quad polygons, so no triangles. Okay, this is I hate to do this in finger quotes. This is a good-looking piece of geo, right? It's all it's not 46 million polygons. Okay, it's a medium resolution, if you will. Something that we can create some simple UVs on, so we can start exploring potentially how the textures are going to work. Okay. And most importantly, we should be able to get a rough approximation with quad polygons of the basic structure. Okay? This then turns into the foundation for the rest of our pipeline. Once we have that good foundation kind of mid-level mesh, it's all quad polygons, then we can start building on it, okay? The prototype stage gives us a good understanding if this is working inside of our real-time rendering pipeline, okay? Usually at the prototype stage, we start throwing it into our game engine and saying, okay, is this going to work, okay? Maybe at this, at the prototype stage, we have too many polygons and it's not rendering the way we want to. Or maybe we don't have enough polygons and it's getting really super ugly and super faceted inside the render, okay? This is going to give us some answers to some other questions that are crucial for us to go into the production model, okay? The production model is, in every sense, the version of the model that shows up in the game itself or in the real-time render. So this is where we have perfect topology, all looped, okay? In the previous version, the previous stage, it just had to be quads, but now these quad polygons, okay, or this quad polygon mesh has to have loops in very specific areas so that this model can be animated, right? If you think of where we're going with this model, or with this stage in our production pipeline, we are preparing this model to be rigged, okay? And once it's rigged, that means it can bend and deform and animate. And in order to get to that stage, we need to have everything in proper edge loops. We need to have structure and geometry in the correct places so it's going to deform correctly. In every sense, this needs to be a perfect model, okay? When we're working out there, kind of by ourselves in just Modo or just Maya, there's a certain degree of freedom we have with our geometry. But when you're working on a very large production team where your asset is going to go from artist to artist to artist, what we create at the modeling stage is going to have an impact of what the character rigger is able to do, or what the animator is fundamentally able to do down the line, okay? In addition, we also have to have final UV maps. We have to pay very close attention at this stage of the model of where our UV seams are, their impact on our ability to create good textures, okay, and the number of UV seams. In the previous one, you just had to have some UVs so you can just kind of start figuring out where the textures are going to go and start blocking out some texture information. In the production model, these need to be dialed, right? These need to be perfect, so that when we go to texture it, we're not going to run into any problems, okay? Another thing that at this stage is just textures. Okay, this is really where the texturing pipeline comes to the surface, and this is when we're at the production stage. That's when we really start understanding the role of the textures in creating the illusion that's in front of us. Okay, this is something that I put in here, and this just kind of always works for my brain. It's just an independent asset. There's no dependencies on this model anymore, right? It's a standalone piece of sculpture that can be placed in any project file or any game on the face of the planet, and it will work, right? And we'll talk about what that looks like when we get towards the end of the class of how to make this a reusable independent asset inside of our production pipeline, okay? Because you're going to put a lot of energy into these models, a tremendous amount of energy into these models. We want to make sure that it can be used in a number of different places, okay? That it's not locked to one project file or one instance of Maya. Right? So that's the 10,000-yard view, right? We create sculptures, we prototype that sculpture with all quad polygons, and then we get very incredibly disciplined and technical on the recreation of that digital sculpture so that it integrates into our production pipeline. Okay? Questions on this? Everyone's kind of feeling, I explained it that good? Yeah? Okay, cool.
Wait, no.
Yeah, question. Yeah.
On the prototype slide, when you say sculptable
Sculptable geometry, yeah. So and I regret the visibility of my triangles. I should have zoomed in a little bit more. But if you look very carefully, and the tongue is probably the best example of this, or the eyeball. They're all triangles. Sure. That's not super hot sculptable geometry, because you're not going to be able to predictably create the edge flow that you need to get the deformation that you're after. Okay.
So when you say that, you mean the ability to redo it?
Yes, just simply, right? If you look at it, and maybe I'll just go back and forth between the slides. And okay, so focus your attention on like the eyeball, for example. Okay. When I was doing my sculpture here, I mean, I went down to scales. I mean, I modeled scales, right? And I wasn't in there like, drawing each individual scale. That's not what we do. We have these things called stamps and texture or alphas, and we can throw down big collections of scales in one mighty fell swoop. But look at the geometry in the eyeball. It's really packed in there. If I want my character to blink, can't do it with this model, right? The triangles and the structure of the geometry is physically going to stop me from doing that, right? Not even possible, right, with this version of the mesh. If I wanted to texture the face or even get some information in the eyeball, I can't do it with all those triangles. The process is physically going to stop me, okay? I zip forward. Okay. Now we have proper loops. They're all kind of flowing in the right kind of direction and the right order. And this is something that I now can manage a little bit more directly. It's still a little too high poly in that area, but at least this is usable. Okay? This is usable. Here's another great example of an area that would get optimized in the production is the tongue. Look how many polygons are on that tongue. That's a lot, right? That's like a 4,000 polygon tongue. That in the final production model, I think that got zipped down to like 100 quads. Okay, so in the area of where the final is different from the prototype. But now at least we have an underlying foundation that we can build and change that kind of makes sense inside of our quad polygon workflow. Cool, huh? Yeah, rock and roll. Everyone kind of dig it a little bit. All right. Okay, let's get out of here and I'm going to zip over to Canvas real fast. And we're going to start talking about our first project, okay? Our first project in here, and excuse me while I just sign in real quick. All right. Okay, so I went ahead and published the week 2 homework assignment, which is going to be a snail. Okay, so we're going to start our kind of foray, if you will, into our character modeling pipeline by starting very simply with a simple organic creature. Okay, now there's a reason I'm going to ask you guys to build a snail. Does anyone want to take a guess as to why a snail? Shapes. And very directly, what basic simple shape is a snail? You got it. It's just a long rectangle, okay, for the base, and then a sphere on the top. You can't get much simpler than that, right? It allows us to, there it is, okay, that's it. Okay, snails are pretty simple when it comes to the overall shape itself. And this is an excellent place to begin. It really is, okay? Because it allows us to understand our sequence, okay? Far too often, people jump. Okay, and I wish I had my slides up here again. They jump from the concept stage all the way into production. They skip that middle one, right? Or they don't even do the concept stage and they just jump into making a final art asset, right? That is a house built on sand. It really is, okay? So by understanding the basic geometric foundation of our model, we then can iterate simply, okay? Because once we send this over into our sculpting engine, it's going to get complex and wildly very quickly, okay? So we need to have a really strong foundation in geometry before we can enter into the wild west of Mudbox, okay? Because it's going to get kind of squirrely pretty quickly, okay? But if everything's built on stone, we're going to survive, okay? In addition, the snail allows us to remember our box modeling technique. Okay, so for some of you guys, this is the first 3D modeling class you've taken. Others have taken a couple with me. Okay, the box modeling technique is a great place to begin because it allows us to, again, start with a simple shape, deconstruct that simple shape, and then to expand that simple shape with simple editing tools to make something that's a little bit more complex. The box modeling technique also allows us to ensure that what we create is all quad polygons, which is a required element for Mudbox. Okay. If it's triangles, we got problems. We got big time problems, okay? It's not going to sculpt correctly, okay? You're going to get these weird facets and artifacts, and at times it's going to pinch and it's going to destroy the illusion that we're creating. So quad polygons are absolutely the brass ring, if you will, that we're trying to grab when it comes to the creation of the geometry. Okay, so the box modeling technique gives us that. Okay, and snails are super cute, right? So cute. Little antennae, right? Little shell. FYI, your snail can look like anything. If you wanted to do something other than a snail, if you really hate snails, huh? If you really hate snails, come talk to me. I want to make sure that you're making something that you love. I don't want this to be something that you struggle with if they really bug you, or if this is not something that you think is going to be fun at all. You know, I'm flexible in this, but I want us to start off with something really simple, because trust me when I say this, once we get to characters, okay, it's going to get stupid hard very quickly, okay? Everyone wants to do characters, right? Everyone on the face of the planet, they want to do characters. Characters are, modeling the human form is just about the most difficult thing on the face of the planet for us to do correctly, okay? And it takes a pretty, dedicated period of time of study. You guys are going to become ninjas at anatomy, okay? You're going to become ninjas at construction techniques, because it's going to be something. Let's just put it that way, okay? So this allows us to kind of slowly work our way up and build some confidence in our own personal production pipeline, so that when we get to the really stupid hard stuff, we're not going to drown and flounder.
Aside from humans, are we going to be able to learn how to model dinosaurs?
No, but I model a ton of dinosaurs, so come find me. I'm into dinosaurs, and my boys are into dinosaurs, so we do a lot of dinosaurs, right? I could teach a class just on modeling dinosaurs, but I think like Dominic and I would probably be the only two that would take it, right? I love dinosaurs. Dinosaurs are a lot of fun. And I resisted the urge, because when I was putting the syllabus together, I was like, we should do a dinosaur. And then I went, wait, I think it's just me that likes dinosaurs. But, if you want to do a dinosaur for this one, Dom, I'm happy with that. I really am. I really am. Yeah, a dinosaur snail. Dinosaurs in themselves are still really kind of basic, simple shapes. They're just kind of a whole series of cylinders attached to each other, and I'm cool with that. I'm cool with that. So I want you to find something that you're really into. I thought a snail would be a good kind of common denominator for us, and most importantly, it's non-human, right? Because human structure is totally different. Okay, I want us to kind of ease into it, because it's going to hit you like a ton of bricks when we get to human anatomy. Okay. All right. With that said, yeah, go ahead.
If you are doing a dinosaur, how basic or how complex does the base mesh need to be before it can be modeled?
Yeah, and that's a good question. And we're actually going to kind of answer that question as we go today, because that's going to be the driving factor of this initial kind of block out of our model. Is how detailed are we looking for here? What is it that we're trying to achieve at the outset of the blockout stage to get something usable in Mudbox?
So I just was wondering this from the homework last week and everything. How do you see other, like, for example, if I have multiple cylinders, how do I see the other cylinder, like on the actual side, like how, for example, how Mono had meshes.
Yeah.
How do I see the other meshes?
Okay. So the question is, if I have multiple cylinders. Okay.
Yeah, see like that. How do you see?
Okay.
Yeah, I'll show you.
So are you saying you want a list, like the list item, the atom list? Excuse me.
He knows exactly what.
All right, great. Okay. Whoops. I just hit the wrong button. Did you figure it out?
Yep.
Rock and roll. Okay. My job here is done, as they say. Okay. So what I would like to do today is kind of jump back over into Maya and start looking at our box modeling technique. Because there are some modeling tools and some techniques that we need to remember and or learn to ensure that what we are creating is usable. Okay? Because Mudbox has a very narrow kind of band of what's usable and what's not usable. Okay? And your ability to sculpt and create something that at the end of that sculpting process that is usable, you can spend you can spend 40 hours on a sculpt, and I want to make sure you're going to get something at the conclusion of that can work inside of our pipeline. Okay. So let's jump in and start looking at it, because there's some ideas in here that we really want to explore. Okay. So last week, we actually kind of did some box modeling last week, right? Oh, I got ahead of myself. Even I get excited about 3D modeling. I just want to jump in, right? Let's take a second and actually remember our craft. Here's my snail. Isn't it just so cute? It's just so cute with the little antennae, little house on its back. I love it. I think snails are really kind of adorable, right? I'm not going to pick one up because they're slimy and illy, right? But but I'm definitely going to admire them from 6 inches or so. Not on my body. So I got this picture from Wikipedia, and of course, you know, we have to be subject matter experts in the things that we create, right? The first step in our modeling process is just research, right? We got to understand what these things look like. Everyone has an idea of what a snail looks like, probably in their imagination. I'm going to guess that at one point in our lives, we've seen a snail, right? From time to time, I unfortunately step on them, which is never fun for me or the snail. But, you know, we've seen them. They're around. There's, as I just mentioned, there's a couple different things about a snail that makes this a good starting point for us, okay, as the first kind of puzzle that we're going to be doing this semester, okay? First and foremost, they're really simple shapes. If you were just to look at this guy for a second, what simple shapes do you see unfold in front of you? Yeah, a whole bunch of cylinders. You got it? What about his house on the back? It's just a sphere, right? If you look at the body of the snail itself, you know, there's a couple different ways that you can go about creating this. It's either just a really long rectangle, okay, or, you know, it looks kind of cylindrical to me, okay? So I would probably start with the cylinder and then maybe just flatten out the bottom side of that cylinder as I start to block this out. Yeah, yeah, that's a good way of approaching it as well, for sure, for sure. When we're blocking things out, and we're going to start this here in a minute, we need to ensure that the detail that we create in the model is representative, okay? At the end of the block out stage, we should be able to look at the model and go, that's a snail, right? Okay? And there should be enough geometry in there that you can understand that this is a snail. I saw someone, and this is just being a lazy game artist, right? They blocked out a human hand in Maya, and guess what it was? It was literally one rectangle for the palm, and then 5 rectangles kind of pushed into it. He's like, and I'm good, we're going to Mudbox. And I was like, no, 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 no. This is not how this works, okay? Okay, we have to be representative. We should be able to see and understand the details of whatever it is that we're creating in the lowest resolution possible, okay? So we need to pay attention to form. We just can't ignore it. We can't just assume that Mudbox is going to give us all these wonderful tools and this wonderful ability to make, you know, super high resolution things. We still have to be good modelers, right? Topology, the structure of our model, is critical, okay? Because if you don't have good topology at your base mesh, Mudbox, or you're going to be fighting Mudbox every single stage. You're not going to be able to sculpt the way you think and want to sculpt, okay? The fluidity of the entire application is built around good structure, okay? So I'm probably going to make mine out of a cylinder, okay? Now, one of the things that we also need to start evaluating and deciding kind of at this stage, at the research stage, is how many objects we're going to have inside of our scene. Is it going to be all one mesh, or do we want to have it separated out into a whole series of pieces, right? Mudbox doesn't allow us to combine things, okay? So we have to make those decisions pretty early on in our process as well. For me, if I was doing this, and we're about to start doing this, okay, this is going to be a 2-object mesh, okay? One for the body, and another one for the shell itself. There's enough detail on the shell that I would like to sculpt on it individually without having to worry and wonder about messing up the body, okay? And it allows me to focus inside of both Maya and Mudbox a little bit more directly. Back to the base just for a second, some things that I see that are really important, okay, when it comes to underlying base structure are the cute little antennae, okay? These are something that I absolutely want to make sure is combined to the base. And I had no idea that they had 4, right? I didn't know that. I thought they only had 2, but the research is telling me they have 4. And I'm going to guess that maybe these things down over here are like the mouth or something.
The ones on the front are antennae. The ones on the top of their head are their eyeballs.
They're eyeballs, okay.
And the ones on the bottom, yeah, that's their mouth.
This is their mouth down here, and then their eyeballs.
Antennae, and then the little, like, they have like a
These little
their mouths
things.
actually are just like full of a bunch of
awesome. I didn't know that. Yeah.
They're very tiny.
Very tiny, very teeny tiny. Okay. The other thing about the shell that makes it something that should be a separate piece is the pattern. Okay. If you look at the pattern of the shell, of course, that corkscrew pattern, that spiral that goes into it, that's something that's not going to be impossible to create over in Mudbox, but it's going to require a different geometrical resolution than the base itself. The majority of the base this is pretty going to be, you know, a pretty low res mesh for the most part, but to get that spiral in there, that's going to take some geometry to get it to look good. Okay, and that's going to be something that we're going to need to look at. In addition, what are some of the other things about the reference that we should immediately be thinking and considering about as we go forward? We have an understanding of the basic shape. We know what basic tools we're going to use to create that shape. What else should we be considering and thinking about while we're researching this? Yeah, absolutely. So like specifically, all of this lovely info in here, right? All these little bumps and grooves and stuff, the actual height of the skin itself on the snail. That's something that we can very easily create over in Mudbox and should, right? Same thing goes for the shell itself, okay? All those lovely like texture lines in here. That's something that I want to focus very directly on over in Mudbox as we start sculpting all this, okay? All right, I'm pretty happy with this. This is a good place. I know and understand this shape a little bit more directly, which will help lead my entire modeling process over in Maya. So let's jump in and start taking a look-see at what we have here. Okay, so let's start by talking about the base, because I think that's an excellent, excellent place to begin. Now, we don't have orthographic reference for a snail, so we're going to have to use the thing between our ears, okay, our brain, in our eyeballs, okay, to help us figure out what the sculpture is going to look like, okay? I'm going to start off with a cylinder. This guy right here, boop, cylinder, okay? Now, this cylinder is going to give us an excellent, excellent foundation for our entire model. This is going to be the base of my mesh, okay? So I want to have the head and the antennae, or the eyeballs and the antennae on this cylinder. And I also want to make sure that it tapers back to the tail. And I also want to just generally kind of get that shape where it's flat on the bottom and then kind of cylindrical around the top, okay? So the cylinder is going to be a good place for us to begin. Now, right now, how many sides does this cylinder have? If you're saying to yourself, crap, I don't know, that's good, right? Because Maya does a very, very bad job of communicating some of these basic details to us initially, okay? One of the both good and bad things about working inside of Maya is that object history. You probably saw this last week when you were working on your wine barrel, right? How do I go, or where do I go inside the interface to access my object history and to make changes to some of the properties and attributes of this object? Does anyone remember? We can go to the attribute editor. There's another place that allows us to very quickly see all the input nodes for this shape.
You were going to show us, but then Maya crashed like 7 times.
Oh. Well, good. Now, this is a good segue then. Because hopefully Maya won't crash. So where we're going to go is called the channel box. Okay? The channel box is going to expose all of the modeling tools and sequential steps that have been performed on this object itself. So let's check it out real fast. You can find the channel box in a couple different spots. Okay? If you're in the Maya Classic window, it may be in the vertical tabs over here. Mine is. Okay? But if you're in Model Standard, it's probably not going to be there. Okay? The place that I would recommend that you go, and if you don't see it at all, it's this button right here. This is the icon that brings open your channel box. Okay? Now I'm in the modeling standard workspace. The channel box is going to be put in this floating palette, which is just fine and dandy for me. Okay? Now I have my cylinder selected, and you can see over here in the channel box it says Inputs, Polycylinder 1. This is the little packet, the little bit of code, if you will, that was fired off and evaluated by Maya to create this shape. The developers down at Autodesk have exposed a number of variables inside of this packet that allows us to change that shape. Please don't crash on me again. it really doesn't want us to go into a cylinder, which is not great because most of this model is going to be a cylinder. Okay, let's try it again. All right. Oops, I'm still waiting for it to load. You know, if this continues to be a problem, there is a way to reset Maya, and I'll show you how to do that. It's actually really easy to get us back to the factory defaults. It's really easy, but it's not as intuitive as I would like it to be, but it is something that's accessible. Okay, so should I tempt fate again and click on polycylinder 1? Let's try it out. Nope, it's going to crash. That's interesting. On a basic poly shape, it's going to crash. Okay. I think it is. And for everyone else, it's probably working, and I've done this a zillion times. Yeah. You know, this is not a criticism of our computer services department, but one of the things I've noticed is that when they deploy, sometimes when they deploy an app to the exact same machine at the exact same time, it causes installation problems. All right. Let's see if I get the exact same result on a cylinder, because it's the exact same idea. No, it doesn't want to do inputs at all. It's no bueno. Okay, so let me try this. So we're gonna troubleshoot live on the spot here, right? So one of the things that we can do to reset Maya and bring back all of its prefs, and it could just be a corrupted preference file that's stopping me from doing this, okay, is that we have to go into the innards of our computer for a second. If you go to the Go menu, if you're in the OS Finder, the Go menu at the top of the screen will give you access to your library, but you got to hold down the Option key. They've hidden it from us because they don't want us to go into the actual library. The library folder is where all of the core OS files have been written, right? So this is in every sense exposing all the root files that run the operating system, which is why they've hidden it, so that you know, grandma who's running the Mac doesn't accidentally delete, you know, something that's going to stop the Mac from working. But for us, we need to go in there. So if we hold down the Option key, open up our library, let's see if Computer Services has allowed us to do this. I hope so. And specifically, where we're going is into our Preferences folder. Okay. Okay. Now, there's a couple things in here that we need to look at the top. So all these things that say like com.apple.textedit.plist, these are all preference files. There are some, what we're looking for is a folder called Autodesk. So one might imagine Maya, and then 2018, okay, and then prefs, okay. This prefs folder is what is generated every time that Maya loads, okay, or the contents of that prefs folder is what is accessed and evaluated every time Maya launches, okay. And there's a bunch of things in here, okay. This basically stores the entire state of Maya into this folder, and I'm going to guess, since I'm getting a pretty consistent crash with a low-level panel, just the channel box, that there's something in here that's gotten corrupted, or maybe it's been rewritten so many times, or I don't know what, okay. However, what you could do, and this is the preferred way of doing it, you want to keep this around. So I always call it old prefs, just in case, okay? Now, when Maya launches, it's looking for a folder called prefs, and I'm going to leave this Finder window open so you can see what happens, okay? So if you just launch Maya, it should create, yep, did you see it create a new folder here called prefs, okay? If it doesn't automatically find a folder called prefs, it creates a brand new series of prefs for us, okay? And that, in every sense, kind of restores the factory defaults back to Maya, okay? Now that Maya has opened, I'm just going to give it a second. Yep. Now I definitely know that everything is kind of back to its factory defaults. It's showing me the new features are highlighted, and yeah, okay, we don't need that anymore. Let's hit OK. And I want to return to my Finder and delete my old prefs folder because I don't need that. I like to keep the old prefs around just in case, like, Maya cataclysmically doesn't restart. At least I have something on my hard drive that will ensure I get some sort of level of functionality on the app. Okay, so let's try this again, shall we? See what happens. And if it doesn't allow me to change my inputs now, I'm up a creek without a paddle. No. Awesome. This is great. This is making my day. It's fantastic. All right.
Some of the computers in the design lab actually had that problem too.
Yeah. I'll ask Vasil to reinstall Maya. Vasil is our computer services representative, and he's responsible for this lab and the design lab. So I will tell him that we're having massive instability errors and we'll need to reinstall the app. This is the shakedown semester for all of our Autodesk products. So this was expected that we're going to run into some major bumps along the road. Okay. Big picture idea is that the input nodes that show up in your channel box are going to expose certain properties and parameters that will allow you to change, like the number of sides going around your cylinder and the subdivision axes. Yeah, is it working on yours, Seth?
Yeah, it's working on mine.
What computer number are you?
I am 16.
All right. This really puts a damper on my own ability to create, though, in front of you, because I need to change the inputs. I just do it in the attribute editor. I mean, you can get to the exact same info in the attribute editor. It's a little bit more easily exposed inside the channel box. Okay, so, all right. Seth, I want to drive for a second. Do you mind?
Yep.
Okay, cool. So I'm on Seth's machine, and he has just a very simple cylinder yet again, okay? And if you look very carefully, this is the polycylinder 1 input node that I was trying to select, and Maya was crashing on me every single time. But if you click on it, check it out. Here's all these different channels that are exposed to us that will allow us to change the properties and the parameters of this base cylinder. One of the things that's important to point out is you can change the radius, okay? The performance is pretty bad. Here's a great keyboard shortcut. It's not even a keyboard shortcut, it's just a shortcut. To make this value in the channel box a slider. Because you can go in and you can do like 3 and it changes the radius, right, of your cylinder. But if you want to turn it into a slider, and that's how I like to work with these things, okay, select the word radius, okay? The entire row or channel is selected. And then in your OpenGL viewport, middle mouse button and drag, and it will interactively change that into a slider. Now, I'm on a remote desktop, and it's only doing it when I mouse up. But on your own machine, you'll see it just kind of grow and shrink and change interactively in front of you. It's a great shortcut, okay? Love it. So you got height in here. Again, that allows us just to change the height. And then the things that are really important for us when it comes to working with the cylinder are, of course, the subdivision axis. And this is the number of sides that are used to create the cylinder itself. And a lot of people are thinking, like, what about sides or, segments or something? No, subdivision axis, okay? If I was to lower this to like 8, it gets real basic, okay? 20 is a good one to start with, okay? I like 20. I kind of work in powers of 3 and 4, so I would probably land on 24 before I go to 20, because then it just gives me a much more consistent circle to edit around. Okay. Now that we're into the world of entering things in input fields, this is kind of a nerdy thing, but it's going to be frustrating if you're not aware of it, okay? Notice where my cursor is. Okay, I'm in that channel, okay? Am I editing that channel right now, the value in that channel? Yes. How do I know? Visually.
Highlighted.
Yeah, it's highlighted. You see the cursor kind of blinking, I'm in the edit mode. If I like 24, and I do like 24, we have 2 options to confirm this. And this is something that's fundamentally different from a lot of other apps, is that when we enter things numerically in a channel box, okay, we have to tell the computer that we're done editing and inserting that value, right? So we have to hit enter, okay? There is a difference between enter and return. Does anyone know the difference? And this is a credit to the Mac guys, the Apple guys, because on their keyboard they've very clearly defined it. Enter is on your number pad, right? Okay? And return is way over here, by your letters, okay? Now watch it, check it out. Let's just put this to 20, for example. I'm going to hit enter on my number pad and watch what happens. Enter. It inserts the value, but it doesn't drop my entry into that channel information, right? I'm still in there. My cursor is still flashing, the number's still highlighted, okay? If I put this back to 24, watch what happens when I hit the return key over where the letters. It confirms it, right? It sets it, yeah. It sets it, okay? So get used to hitting return, okay? That way it will save you a couple extra mouse clicks, okay? Because if you don't hit, if you hit the enter key, then you have to go back to the. Say again?
I feel like enters to preview it and returns to set it.
Like actually confirm it. I think that's a great way of looking at it for sure.
Would you happen to know if this is pretty much the same concept on Windows?
Identical, yeah. The only key binding that's different on the Mac and the PC is the Option key, okay? And Control. I apologize. So Option, you know, on here on the Mac, we're Command button centric. Okay, the Command key is equal to the Control key on the PC, and the Option key is the Alt key on the PC. So those are really the only two differences. Everything else is the same. Okay, so that's going to help you out, save some frustration, because you enter in a value, hit return if you want to confirm it, and go on. All right. All right. So the channel box is pretty cool. I like working with the channel box. Okay, but from time to time, we're going to need to. Oh, let me do this real fast. Okay, and I thank Seth for his help. Let's do this. I'm going to jump into the modeling toolbox, and I'm just going to select some polygons here at the top. Forgot that one. There we go. And let's just run extrude. Same thing goes for in here. If you select the option, just like the channel box, if you put your cursor over here and middle mouse click and drag, now it's interactive, okay? You can also do it, this is an interactive slider. If you want finer values, hold down the Control key, okay? Now we're going to get finer attenuation in those values, okay? Okay. Oops.
Does that only allow you to go up to 3 decimal points? Because I was not able to, when I was working on the wine barrel, I wanted it to look like smaller offsets that were like 4 decimal points, and it just like.
Wow. Okay. I don't know. That's a good question. Maybe. I don't personally. I've never had the need to go more than 3, but that could just be a system preference that we can change. I don't know. That's a good question. Good question. All right. All right. What I'm going to do real fast is that I'm just going to do some very simple modeling on this, just to give us a whole series of inputs. Okay. Does anyone remember how to repeat a tool, to reapply the tool over and over and over again? The G key. So I'm going to do another extrude, and this time I'll just do like an up, and then I'll hit the G key again, and I'll do an offset going the other direction, G key, okay, and yeah, shoot, let's just call that a day. Q key to go back to my selection tool, and life is good. Okay, I'm going to zip back over into object mode, because when you're in object mode, then you'll see all the inputs inside your channel box. And check it out. Since I did a whole series of extrudes, okay, I see that listed. So the bottom of the list is always going to be the first tool, the first command that we fired off and evaluated inside of this session, okay? And then it adds it on top. The cool thing about object history is that we can go in and kind of go back in time a little bit, okay? I can go back to the initial polycylinder create node way down over here, and I can make changes, right? Now, sometimes this works beautifully, sometimes it doesn't work beautifully, depending on what you've done. But the point is that whatever history we have in our input nodes is available to us, okay? So maybe I go in and change my subdivision axis from 24 to 8. See, it kind of robbed me of of all of this now. But let's see if 8 was not what worked. Let's do this let's put it back to 24. Yep. Okay. I wonder, I'm just curious at what point. Yeah, at 19. Yeah. And for what I've done here, this is not working all that well. But let's see. Yeah, that's kind of fun. Yeah, and now it's turned into this just weird garbly gook. Okay. So this command history allows us at times to go back and make some changes. Now, in all honesty, the shape creation nodes don't do a whole lot for us. But it is nice to be able to go back in on like a poly extrude or a bevel and have access to all the channels that were used to fundamentally do that operation. Okay, I've done that all on bevels before. Go back in and resize the offset to get you, to adjust the chamfer or the bevel settings. It's pretty cool. Okay, I went the wrong way. There we go. So now I'm changing the thickness on that top bevel, and I'm continuing to make some changes. Now, one of the things that we need to be mindful of is this object history, because it's going to come back and bite us all often, okay? And we need to be able to go in and remove this object history to unhook this object from all the previous modeling steps we've gone through, right? This is called deleting the history, and it's really easy to do inside of Maya. It's actually wicked easy to do. Let's just do it real quickly. If you've been modeling for a while, okay, and you notice all of a sudden that Maya is starting to bog down and get really clunky, right? The performance just evaporates. Select the object that you're working with and look at its object history. I forgot to delete my history a couple nights ago, and I think I had probably 200 different input nodes on one object, which was leading Maya to basically come to a complete crawl, okay? So we want to delete our history from time to time when we get to major destructive edits or to a point in the modeling process that we're okay moving on from our past, okay? Deleting our history is really easy, and it can be done in a couple different places, okay? Specifically, if you go to the top of the screen, there's an Edit pull-down menu, Delete by Type, History. Now, there's two different delete by types in here. There's delete by type and delete all by type. What would you imagine? And then their pull-out menus are almost identical. What is this doing, you think?
One of them's for a selected object, and one of them's for
Everything. Yeah. So be careful with this. Be careful with this. Delete by type is only going to delete the history or whatever you choose from this list for the selected object. Delete all by type is going to look at every single object inside of your hierarchy or in your outliner, and it's going to delete all the history for everything. Okay? So it's kind of a complete, like, blows everything up, right? This is something that we're going to be doing often, deleting our history. So the developers have given us a really great button inside of our poly modeling shelf to do this. And it's this one right here. Delete by type. It's going to delete all of your construction history. Okay? So I got my little cylinder thing selected. Delete by type. Bloop. You can see all those poly inputs go away. Okay? We've deleted them. They're no longer available for evaluation. And now we're a step closer to making a true independent non-reference mesh. Okay? There's no inputs that are influencing the geometry here, so we don't have to worry about the past influencing the future. Okay? It takes a little bit getting used to this input, this object history, but it's not too bad when we get right down to it. Okay. All right. I want to give this back. Thank you, Seth. I appreciate you letting me borrow your machine for a couple minutes, and let's see if I can get this working on my side again. Okay. That makes sense on the input history. Okay. Please make sure you're deleting your history from time to time. It honestly is going to help. Now, the other thing that we need to be very mindful of when it comes to cylinders, and oh, I'm just so nervous now. Okay. All right. The other thing that we need to be very mindful of when it comes to cylinders inside of Maya are the caps. Okay. A lot of times we take these caps for granted. What surface type are the caps of my cylinder? Triangles. We know the triangles. We want to try to avoid triangles as much as we can. So we need to go in and start slicing up the cap to get it into all quad polygons. Okay? And this is where, excuse me, this is where our construction practice should begin when we're working with cylinders. Okay? Now there's a couple different ways that we can do this. Okay? And a couple considerations that we need to keep in mind. Okay? We're going to be using multi-cut to do this, which is a great tool. But to get to a situation where we can have a gigantic n-gon that we can very quickly slice into a whole series of quads, there are a couple little nuances. Actually, one is not a nuance. One is a gigantic pitfall. It is a pit of crocodiles that will eat you alive if you're not aware of it. Okay? Let me show you what that crocodile pit is. I want to go in and start deleting some geometry, okay? Let's just do it and run into the modeling toolkit here real fast. I'm in my surfaces selection mode. I'm just going to grab all those top polygons, okay? And I'll do the same for the bottom, maybe during the break, okay? Now, I want to delete that cap and then fill it real fast, okay? Now, the convention would be, oh, just hit the backspace key. Boom, it's gone. And that's not bad. But there's a small little problem that we've created. Bingo. It leaves the vertices. It's a pain in the rear, right? And this is a fundamental shift and major difference between a lot of the other modeling operations or a lot of the other modeling tools out there in our world. That when you hit the backspace key, you're deleting the surface and not the vertices that are associated with that surface. Let me prove it to you and showcase very directly what I'm talking about here. I'm just going to hit undo, go back a step, okay? And this time, I'm going to drop my selection as well. This time, I'm just going to zip over to the multi-cut tool. The multi-cut tool is pretty great. You're going to use the multi-cut tool a lot. It allows us to slice, you know, in between like this and add new edge segments, okay? However, if you hold down the control key on your keyboard, it's going to slice and do a loop slice and a loop. Boop. Okay. So I just gone ahead and added a loop in there. In addition, I'm going to do a couple other viewport modifications just to help us see some things. Okay. Let's do this. Okay. I'm going to go into the display properties. And if you like seeing all the verts, okay, because some artists out there love seeing all the verts on their surfaces, this is where you go to turn it on. Okay. So in your display pull-down menu, display, polygons, and then vertices. Okay, there they are. Now, I don't know about you guys, but those are stupid small. Can you guys see those little verts on the screen? I'm like inches from it, and it's hard for me to see. So you can change the vertex size of all this as well. I'm sure some of you guys saw it inside of your, yeah, right there. You make them bigger. I want to make mine gargantuan, that's why. So Andre and Sophia in the back can see them. There we go. Can you guys see those verts? A little bit easier to see, right? All right. All right. So check it out. Now that we can see our verts, we can see exactly what the backspace key is going to do. I'm going to flip over into my edge selection state and simply double-click on an edge loop to select all of it. Okay? Now, if I was just to hit the backspace key, look what happens. Okay? All the verts that were on that surface and that created that edge loop remain in the surface itself. Thumbs down, massive thumbs down. This is going to cause huge problems inside of our modeling sequence if we're unaware of it, right? This is an often stumbling spot for people. Modo does a great job at this. Maya does not do a great job at this, okay? Hitting the backspace key is going to remove all those verts. In other applications, it's not just Modo that does a good job out of it. This is something that's unique and different for us in Maya. So how do we get rid of that? Because I want to delete that edge, but I also want to delete all the verts that are associated with that edge. Did anyone figure it out?
Command.
Or control. Yeah, control backspace. Okay, it's going to delete the edge and all the verts that are associated with that component. Okay, same goes for polygons. Okay, let's jump up to the top here. Okay, now if I simply did backspace, it looks like we're good, right? But watch what happens and how the mesh changes when I do control backspace. I know it's faint. If you're following along in your machine, you probably saw it, but it has selected that top row of edges on the opening. And it's now created what's called a boundary edge. Okay? This is good because now the mesh is kind of terminating at that opening, which is what we want. Okay? Here's the 10,000 yard big picture idea. Get into the habit of doing control backspace when you're trying to delete stuff inside of Maya. Okay? It's going to solve most of your problems, okay? Most of your problems when it comes to editing your mesh. Now that I have a boundary edge on my model, I can fill it, okay? And that's found under the mesh tools. Fill hole, okay? Before we go any further, this is my little disclaimer. I'm horrible at lists. Like, I'm god-awful with lists, right? It is my Achilles heel. And Maya forces me to work with lists. And in my little simple brain, there is not a difference between the mesh, the edit mesh, and the mesh tools list. They are all the same to me. They really are. So if you see me hunting and pecking through these lists, it's just because my brain it doesn't separate them very easily. Huh?
It is a lot of lists.
It's a lot of lists, and they do a very bad job. Because, like, what's the difference? I just don't understand it. What is the difference between edit mesh and mesh tools? I don't get that, right? Because you find mesh tools in all three of those lists, and you can edit your mesh in all three of those lists. That's it, right? It'd just be a mega list if it. I just don't get it.
Some of them that I've never opened.
Yeah. Anyways, okay. So fill hole is a great way to fill your hole. And to close some stuff up pretty quickly, okay? Now, there are a zillion different ways that we can go about doing this. This is just a way. But now we have a surface that we can very easily continue to go in and slice and get into quad polygons, okay? So I'm going to zip over into the top view here real fast. And we'll get to work, okay? Multi-cut's a great tool. It allows us to very quickly connect the dots, okay, like that. Can you guys see that? I know it's faint. Yeah, it's tough, and I get it. It's really tough. This other one? Sure, let's do it real fast. When it comes to working with cylinders inside of Maya, or any app for that matter, we have to be very aware of the pattern that we're creating. Ultimately, what we're after is what's called a quad disc at the top of our cylinders. We don't want triangulation at all in our meshes. So this is kind of part of our responsibility as 3D modelers to go through and remove these caps, okay, and build our own, okay? It's good practice. It's going to set your foundation in stone. Now, when you're working with multi-cut, you can do one cut, and then you need to hit right-click to kind of reactivate multi-cut, if you will. So I just right-clicked, and now I can slice through. Oops, I didn't hit right-click. Let's try that again. Okay, let's just hit the G key. Hold on a sec. I may not be slicing. Yeah, I'm trying to slice from the bottom. That's my fault. Go back in time. Let's try this again. There to there. Right click. Yeah. Okay. One of the things that I try to do when I'm doing these quad discs is that I try to establish the center lines from my mesh pretty quickly, okay? And if I drop the tool, go to selection, here's the center line, and there's the center line, okay? I try to establish that north, south, east, west, cardinal poles kind of thing, or cardinal locations, not a cardinal pole. That's something different. I apologize. I try to get those pretty quickly because that's going to lead my entire modeling sequence. We want to start slicing into quads, okay? And the 3 slices that I've done here has made a whole series of quad polygons. And now we have some decisions that we have to make, okay? 3D modelers are good with patterns, okay? And I think I'm going to repeat the pattern that I just did vertically, horizontally. So instead, let me go back to multi-cut. Instead of doing this, which a lot of folks are going to do, okay? You could do that. That's fine. This is a compliant surface type. Those are 2 quad polygons. They're just real kind of thin. They're kind of small. You know, at the very least, we want to try to get all of our polygons roughly the same size, okay? If everything is roughly the same size, they'll subdivide equally and give us a better sculpting experience, okay? So you could do that. That's fine, okay? However, what would it look like if we did this? Go from there to there. That's interesting. Once again, right-click to refire multi-cut. That's interesting. Now look at these polygons on the inside, especially this row. They're all generally the same size, and I appreciate that, okay? Ta-da! That's a good place to begin. It's a good place to begin. Okay, and I do the exact same thing down there at the bottom. Now what this gives us, and what this really ultimately allows us to do, is continue our box modeling technique. Okay? Let's go back over. I'm going to turn off the visibility of my vertices now, just to kind of clean things up a little bit. Display, polygons, I'll turn off vertices. Okay? I'm going to turn on the grid as well. This is where you go to make your grid. Turn your grid on. And let's start orienting this a little bit so that we have certain features of my mesh already kind of pointed in the right direction. Okay. So I know by looking at my compass that this side of my grid is the center of my three-dimensional scene, or excuse me, the front of my three-dimensional scene. So I'm simply just going to rotate this. Hold down the E key to fire off rotation, J to do a little bit of snapping. Come on, fingers. There it is. And this is really small, so I'm going to scale this up as well. There we go. I'm happy. So this is the front, and this is the tail of my snail. Okay. Slicing this front into a whole series of quad polygons really allows us to continue box modeling in that area, right? Because we got the eyeballs that we need to kind of bring out, and we also have those little antennae down there at the bottom that we need to figure out how we're going to do as well. With quad polygons established in this area, we have a lot of options now. Okay, we have a lot of options. Okay, let's continue to block out some stuff, and then we'll take a break. Okay, because right now this shape is really super small. Okay, it's not representative at all to what my picture says it should be. Right. The snail is pretty long along its length, and it's got a big shell on the back as well. I need to start establishing those basic proportions right now. Okay? So this is where we're going to explore. Make a selection, W to access the move tool, and let's just see how long we want these things to be. Now, without the shell in there, these proportions are kind of tough to establish, right? How big does it need to be? How long does the body need to be in relationship to the shell? And this is why we want to start throwing in maybe some sort of rough approximation of the shell as early as we can in this process, okay? Proportion is important, okay? I'm just going to start with a sphere. Now, where is my sphere? I added one, but where is it? It's inside my cylinder, okay? What's an easy way for me to select that sphere and continue modeling with it?
Select the object mode and then move it.
So go into object mode, but I don't see anything in my interface that says that this is selected. What can I do?
Just gotta believe.
You just got to believe, man. I like it. You just got to believe. And that's cool. I'm happy with that idea.
You could select all the faces of the cylinder and hide it.
You could do that, absolutely, and that was a question that popped up earlier, is how do we hide things inside of Maya? Okay, so if I wanted to hide my cylinder to expose my sphere, select your cylinder and then go to the top of the screen where it says display, and there it is, hide. Then hide selection. Bloop. There it is. Okay, that works. Now if I wanted to get my cylinder back, what do I do? Huh? Kinda, okay? And I have hit and miss success with just hitting H again. I just go back to Shift H, show selection, or show less hidden, Command Shift H. Okay, Command Shift H, oops, I don't have anything, let's just do this. It failed, this happens all the time. Show less hidden, no previously hidden objects to show, so let's go display, show selection, I don't have anything selected. Show all, there it is, okay. Really where I was going, and one of the things that I would encourage you to have access to, either understand where it is or have it on your screen at all times, is the outliner. The outliner, this guy under the Windows pull-down menu, is a great little popover that's going to show you a list of every single thing inside of your scene. So now I can just go over and select my sphere, hit the edit tool, and there it is, I'm ready to rock and roll. Okay. Okay, I'm going to zip over into my right view. And now I'm just thinking about scale and proportion. How big is the shell going to be in relationship to the body? Where is the shell going to be in relationship to the body? These are decisions that we need to start blocking out and understanding now. Before we start modeling the eyeballs and the antenna, or just kind of figuring out the overall detailed shape of the snail itself, let's think proportion. Okay, let's think broad brushstroke as much as we can. I always like to encourage folks to go back to the classical sculpture world. One more 3D modeling, okay? Imagine that this is literally a whole bunch of clay in front of you, okay? If you were a classic sculptor, you'd grab a hunk of clay and you'd just like press it on top of another piece of clay. And if it's too big, you start just taking parts away, right? And then you look at it and say, okay, are the proportions of these elements kind of jiving with what my brain says, okay? And if it's too small, you grab more clay and you press it on there to increase the mass, and you start adding things in or subtracting, you know, with these very, very rudimentary kind of ideas. So I'm just exploring now, and I have no idea where I'm going to go with this, okay? Is this too big? What does my reference say? Okay, so the reference, the shell is pretty low to the ground, okay? Now, if this distance here, if this is the head, okay, and if this is the tail, and if this were the, if this is where the shell is going to be, is this distance here what I want it to be? No? Is that better? Now, I'm not looking at the tail. I'm just looking at the distance between the front edge of the shell and what could be the front edge of the head. Is that kind of closer to what my brain says? That's a little bit better. Okay? Before I go on, let's look at it in perspective. Looks kind of silly. It's too big, it's too bulbous, but that's okay. We can continue to refine that. Maybe a simple disproportionate scale along the x-axis will help me get where I'm going to go. Yeah, I'm happy with that. I'm just looking at proportion. I'm not trying to model details yet.
You recommend rotating the sphere so that you have the spiral on the side?
That's a great idea. It's a great idea. I don't think it's going to be as big of an issue for us now. But when we get to the final retopologizing stage, then we'll need to look at where the poles are, for sure. That's a great consideration. I think there's no reason not to do it. Yep. Okay, so now that I've established the distance between the front edge of the shell and the front edge of the head, I can go back to this other object and focus on where I want the tail to be. Okay. Now it looks like from the picture, oh, I had it wrong. The tail is pretty short. Okay, so I went way too far. Something maybe right around in here. Ish. Voila, there's my snail. Right. Now we're not nearly done, but at the very least we're starting to block out some proportions. Okay. Now the next thing that we need to do, or that I would like to do, is to start exploring the overall shape of the base. Okay. Because there's some important ideas in here that we need to capture early on. Notice that I'm not talking about the eyeballs. I'm not focusing on the antenna yet. I'm not talking about the spiral and the shell. I'm trying to focus on the broad brushstroke, big features. Overall shape and proportion first. Details last. Okay? I'm not thinking about the texture on the snail or the awesome lines on the shell or what color it's going to be. That's not where we're at right now, right? We're just trying to block out the basic shape and proportion between all these different pieces so that the sculpture makes sense. Okay? All right. So one thing that we can do that's kind of fun, and this is a good time to explore it, is looking at soft selections. Okay? Because what I want to have here is a shape that's more cylindrical on the top, but kind of flat on the bottom. Nothing in our world is made up of 90-degree lines unless you're a building. Okay? If you're working in the organic space, everything is a cylinder. There are no straight lines in nature. Okay? So we should try to avoid perfect 90-degree edges and very quick transitions between planes. Everything in the organic space has some sort of radius associated with it, right? Now I want to start bringing those radiuses in to my sculpture, and I know this is going to sound strange considering what I just said, but I want to start flattening these objects out, or I want to start flattening the bottom. Because if you look back at the reference, really cylindrical on top, very flat on the bottom. Okay? And then it tapers. It goes down to a nice little point at the end. How are we going to do that? Okay? Soft selections in Maya are a great tool for us to make those kind of big, those kind of big changes. What I'm going to do to start off, well here, let me just kind of demonstrate what this looks like by going over to my sphere, and then we'll move on to the actual base of the snail. let's say I want to go in and edit a big chunk of polygons in here. Okay, I want to pull this out, but I don't want to pull it straight out. I want to pull it like along a curve. Okay, if I was just to select those polygons, and I selected too many, excuse me. There we go. If I was to go in and just fire off the move tool, this is what I get. Okay, I want to make sure that this is still an organic shape, so the soft selection is probably a better way of working. Okay, let me show you how the soft selection system works. Instead of grabbing all 12 of these polygons, I'm going to grab just maybe one on the inside. Okay, this time I want to do the exact same thing, but this time I'm going to enable soft selections, which is a great system inside of Maya that I think you'll honestly enjoy. Okay, over in the modeling toolkit, you can turn it on right here by hitting the soft select. Okay, or there's a keyboard shortcut, and this is an important keyboard shortcut to remember because you're gonna bump it on accident. Okay, and it's the B key. B as in boy or Bravo. Okay, and you're gonna go, what is going on? Why is my mesh all these multicolors now and nothing is working the way that it worked 2 seconds before? WTF, panic, run out of the building screaming, right? They've put the keyboard shortcut in the worst place possible, and that's right down there next to the space bar. And you're going to bump it on accident. It happens all the time. I do it where I bump it on accident and like soft select's on all of a sudden, right? So the B key is what turns it on, okay? Now soft select allows us to select a point, and now we're creating a gradient across our mesh, okay? And that gradient is going to influence all the geometry inside of where it's colored, okay? Let me show you what it does, just so you have a point of reference, and then we'll talk about how we're going to control it. Now keep in mind, I have that polygon selected, and I have the move tool on. But with soft select, okay, see how we're not just moving that one polygon, now we're moving a lot of polygons, but there's a fall off, okay? You know, the move tool is being influenced by that colored gradient across the mesh, okay? And it's a really, really neat system. I like the soft select system, but it's a fun one to access and control inside of Maya.
Is this the only sort of link to the fall off in Moto?
Yeah. Yeah, there are some granular settings of... Yeah, there are some additional settings that kind of extend the power of it. You're honestly only getting about 1% of the soft selection properties over here, okay? But let me show you a really important modifier, if you will, of the soft select system. So B turns it on and off, okay? But if you left click and drag while holding the B key down, you increase and decrease the radius, okay, the area that you're influencing in the viewport. See how that gradient is shrinking? And then if I make it bigger, now I'm influencing much more of the mesh, right? The area of influence is growing. So you control that by pressing and holding the B key and then dragging with your left mouse button in the viewport. So we can do just a little bit, or we can increase the radius and do a lot, okay? That's how soft select works, and it's a great way for us to go in and organically change the shape of our objects. So I'm just going to go back in time, a couple steps, right there, that's good. And once the soft select system is on, you can see that it's always on, okay? In component mode at least. See, I've gone to a different piece and it's still on, so hit the B key, turn it off, and now our tools are working the way that we want them to. Now I'm going to take advantage of this soft select system by pairing it with a couple edge selections. I've just grabbed that bottom edge right along my cylinder, and if I turn on soft select, there we go. Let's just just move it. Yeah, there we go. See what I'm doing there? Yeah. We're creating an area of influence for the tool, okay? It's like almost kind of feathering the influence of the tool across the entire mesh. It's a really great system. It allows us to control large swaths of our model all at one time, okay? So we do the exact same thing with these polygons over here, okay? Sometimes we have to be a little bit creative in what we select to determine that we're getting the result that we're after. Like I want to try to get that taper that goes from inside of here, okay? And I think, in all honesty, I need to do some multi-cutting. Let's just add a poly loop right in there. That way I can just maybe try to move those verts down, back to the selection tool. And I'm going to go back into my vertex selection engine, and this may or may not give me the result. I didn't have a chance to slice this into quads. But I'm going to select that one vert, okay? The component that we select is going to receive 100% of the influence of the tool, right? So it's like the dead center of the gradient, of the soft selection gradient. Now, the gradient is going to emanate from that point, or whatever is selected, in the center of the selected component, right? Oops, I dropped it on accident. Yeah, that's interesting. Not exactly what I'm after. I don't think I have enough geometry in here to get honestly what I'm after. But let's increase the size of my radius and do it again. That's a little bit better, but I'm moving the bottom bit. So there we go. What I'm looking at here are the vertices that are not selected. Let's try that. Yeah. Sometimes it works beautifully like it did on the underside. Here I think I'm forced to go in and do a couple other moves to get the tapering effect that I'm after. Okay. I'm going to make some changes to the left side that I want to have automatically happen to the right side of the block out of my snail. Okay. Generally speaking, I want to try to keep this as symmetrical as I can. I think what I'm going to do is that I'm going to start moving this stuff down like this. But I want to have both sides updated at the exact same time. Maya has a really great symmetry system. It's really kind of best in class. It's rock solid. We've got to turn it on, okay? So if I turn symmetry on, object X, okay? Now when I select that side, see how the other side's automatically selected? That's pretty cool. I like that. Maybe I go in. I'm going to select some of these. Yeah, I don't have enough geometry in here to get what I'm after. But, point being is that we don't have to struggle through the edit stage of this, okay? We could go in. I'm going to manually make the taper that I'm seeing in my mind. Something that looks like this. Luckily for us, the soft selection system allows us to get the edit that we're after. Or excuse me, the symmetry system allows us to start having the conversation about what this looks like. Without quad polygons, it's always going to be kind of nasty. But at the same time, that's a quick 2-second kind of taper done. That's not smooth and consistent at all. But without the right geometry in there, the model's kind of fighting me. And I think you can actually begin to see the impact of triangles on our ability to sculpt and craft out and block a good model pretty quickly. I'm fighting it down here, which is resulting in some really bad geometry. Yeesh, that's not good. Okay. Shoot, at the very least, I should try to go in and flatten some of this stuff out so I can make it work. Okay. That's kind of driving me crazy. But I want to get that into quads, and I certainly don't have enough edge loops going back to get the taper that I'm after as well. Okay. So symmetry, use symmetry. Okay, use the soft selection system. They're a great way of influencing large chunks of our mesh quickly to get the result that we're after when we're blocking things out. I'll tell you what, I've been going for almost 2 hours. Now's an excellent, excellent time to take a break. And then I want to come back in and just talk a little bit maybe how we can put together the eyeballs and the antenna, and then I'll let you guys get to work. Sound good? All right. Okay, so one small change to the interface. I really, when you're up close seeing the selection color for the surfaces and the faces is not so bad, but at a distance it's tough to see, and I want to make sure, especially the folks in the back, can see what we're doing, right? So if you want to change some colors, you can, and you should, okay? Customize the interface to make it work, okay? You can change your colors by going to Windows, Settings and Preferences, and then there's a Color Settings menu, okay? Now, this is an intimidating space, okay? Because there's a lot of options in here, right? But for the polygons, okay, so for this in here, it's under Active, Components, and then what we're looking for is right here, Polygon Faces. This little slider, so at the very top here, these are all the preset index colors that are available to us, okay? These little sliders kind of cycle through all of these colors, okay? So I'm going to find, here's Polygon Faces. I want to put it at yellow because I think it's really easy, a whole lot easier for you guys in the back to see the yellow. Yeah?
So where'd you get to that again?
So it's under the, let me hit Save. So it's under Windows, Settings and Preferences, Color Settings. Explore this. It's really helpful. All right. So one of the final things I want to talk about today that will help you construct the block-out mesh for your snail is maybe exploring those eyeballs for a second, okay? Now, if we look back at our reference, okay, what general shape are those eyeballs coming out the top of our snail? Yeah, the little spheres at the top make sense, it's an eyeball. Then underneath them, the gigantic cylinders, okay? So I really need to have a cylinder going into another cylinder, okay? Our box modeling technique allows us to do this very directly, okay, with the extrude tool. I'm going to pretend that I want to have an eyeball coming out kind of like right here and then going straight up. So if I want to have an eyeball or some sort of shaft coming out from the base here, I need some geometry to define the start and stop points of that shaft, okay? And this is where multi-cut really excels because holding down the control key allows us to loop slice, okay? And I'm just going to put in a couple loops like that. Looking good. Hit the Q key to go on, and now I have some geometry. Maybe I'll do this in symmetry. Object X. Yeah, so now I got to figure out where I want that to be. Maybe right around in there. Let's run extrude and see what that gives us. Now, this is, on the surface, this is kind of the direction we're going, right? But at the end of the day, we still want all the details to look as they would in the reference photograph, okay? We can't rely upon the awesomeness of Mudbox or the sub-D surface engine to create the shapes for us. We need to be good modelers. I want these shafts to look cylindrical, okay? Now, it shouldn't come to anyone's surprise why they look like rectangles, because the base are rectangles. The shape that I was extruding is a rectangle. So really what I would like to have is a shape that looks circular, okay, that I then can extrude out, okay? So I need to have some circles imposed upon my mesh, and it's really easy to do that. We're going to use a couple different tools here to get the end result, but the takeaway here is twofolds. We're going to look at the details of the Insert Edge Loop tool, okay? In addition, we're also going to look at a tool called Circulize, which is really neat, okay? And I like Circulize very much. Now, in order for us to create a circle right there on both sides, okay, I need some more geometry. There's only four verts that comprise that surface. At the very least, I'm going to need 6, maybe even 8 if I'm lucky, but 6 will at least start the conversation. It will generate a surface that's generally circular. I would like, because I'm super OCD, I would really, really like to have an edge loop running down perfectly in the center here, okay? The multi-cut tool is really rad. There's some good stuff in here. But one of the things that it doesn't do very well is putting an edge loop right smack dab there in the center, okay? I think it does if you hold shift. But I want to draw, I think that's the center. It's kind of snapping to that point right there. I believe that's the center of the edge loop, but I would really like to know precisely, okay? So I'm not going to use the multi-cut tool. I'm going to go in and I'm going to use the Insert Edge Loop tool. Okay, now there is a difference between them, and there's some properties in the Insert Edge Loop tool that one should be aware of. okay? So let's just do it real quick. All right, I'm going to start off by selecting the poly loop that I want to slice. To select the loop, does anyone remember how to do it? Yep, you got it. So I got that one, and I want to select all of these guys going down that way, right? So if I select the first one, hold down the Shift key, then double click on the next, double click, there, oops, come on now, Pat. There it is, nope. I'm just having a day today. Is this not a loop? Maybe it's not a loop. Did it on that one for some reason. This one's not registering as a loop. There it is. God. Like I said, it's the end of the day. I'm pretty sure the computers revolt at the end of the day. And my install of Maya is crazy buggy, as we've seen already, so I apologize. But clicking one, then holding down the Shift and double clicking should, and it's not doing it, there it is. It's selected the loose. All right, so let's go ahead and jump in and start working with this Insert Edge Loop tool. It's pretty great. There are some nuances behind it that I want to make sure that everyone's aware of, okay? Have you ever wondered, as you worked inside of Maya, why all the tools, well, not all of them, but most of the tools have these little squares next to them? Does anyone know what these squares represent? Because here's the Insert Edge Loop tool. Settings, okay? This is how we get access to our tool settings that will change the behavior of the tool that we're trying to activate, okay? Now the Insert Edge Loop tool, if we just ignore if we just use the default settings, allows us to interactively go in and add an edge loop inside of a loop, okay? And I'm defining where that goes. And while the tool is still on, this works very similarly to that of the multi-cut tool. I'll go back in time, hit undo, okay? But I don't want to have a new edge be placed, kind of where I decide. I want it to be right smack dab in the center. So let's go back to the Insert Edge Loop tool. But this time, let's examine the tool settings, okay? And there's a couple that we need to be very mindful of. First and foremost, equal distance from edge. That's going to put it right there in the center, okay? Let's do it. Boom. Not in the center. Why didn't I do it? Equal distance from edge loops. I should have done it. I'm now grumpy that I didn't do it. Relative distance, equal distance. That should be oh, it puts it in the center, and no, it's still doing it. Well, I have seen in the past, and I have experience with it, just putting it right in the center. But what I'll do, let's force it. Maybe if we use equal modifier. There we go. Now it's putting it right in the center. And I put the number of edges to 1. I made it win, or I win. I refuse to let it win. Okay. So for me, for this instance, the equal distance from edge, it should have worked. But I had to use multiple edge loops, use equal modifier, and I put the edge loops to 1, and it did it for me. Put it right smack dab in the middle, which is what I want. Point being is that the larger tool settings here on a number of our tools are going to expose some additional variables that are important for us that will give us access to things. Like for example, if I wanted to have like 3 edge loops in here that are all evenly spaced, changing the number of edge loops and then using the use equal multiplier is going to evenly distribute all those edge loops within inside the selected loop. Okay? You're not going to get that with multi-cut, and you're not going to get that functionality with the default settings of the tool. All right. Blink. There we go. I'm happy with that. We'll go back to the selection tool, and we're on our way. Now that I got a couple surfaces in here that have some verts that, these 2 polygons have 6 verts, which is what I want. Now I can run circularize, okay? Which is a cool way of getting circular shapes. Let's see if my symmetry will work. Did it select those? Nah, it's not working at the moment, but that's okay. Let's keep going for the time being. All right, so circularize can be found under mesh. Not mesh, edit mesh. There it is right there. Circularize. And it's going to take the selected components, and as one might imagine, it's going to move their verts to a spot with our circle. Okay. Now that's ugly geo, but luckily for us, the properties that pop up will allow us to make some very small changes, like the radial offset. The circle was just too big. Okay. In addition, the twist, I want to adjust that. Let's twist that around. There we go. Now, if I go back to my selection tool, I have something that I can begin to extrude out. That will look a little bit more representative to what I'm after. Okay. Circularize, which is pretty cool. Yeah, it's a good one. You know, another thing that you could do before you run Circularize is that if you'd like, I'm just going to use this with multi-cut. There we go. Oops. Yeah, you could slice in another, the location of that's not going to work given the flow of this, but you could put another one in here, like that. There we go. It's not connecting it. There it is. Oops, no. Okay, so this happens from time to time, and this may be a result of me starting and stopping 8 bazillion different questions during break. But you know, let's troubleshoot this on the spot, because I have an edge flow issue here that we need to resolve. Our topology is all kind of wonky, and this just happens from time to time. So here's what I'm going to do. I'm going to delete that polygon. Control backspace, get rid of it. Okay, and now simply I'm going to bridge it. Yeah, see how I'm not selecting it? It didn't slice through that one. There it is. I just didn't have the right one selected. We'll bridge it. Yeah, all right, so we got some problems here, big time problems, and I got to do some investigation. 3D modeling forces you to problem solve, yeah, and as I roll over this part of my mesh, I have one edge here that's spanning what I believe to be not the correct number of polygons. So I'm going to see if I can fix this. There's any number of ways you can fix this problem. Sometimes the easiest way to fix some geometry problem is just to delete the problem, to delete those surfaces. Yep. Especially if they're planar. Look, it left an edge in there. Control backspace. Backspace. No, it really doesn't like to get rid of that thing. Let's do this. Let's detach it. See if that worked. Nope. No, it's connected to a couple different things. You know, I was messing around with merge earlier, and this may be a result of that merge sequence that I did.
Did you duplicate those edges when you were cutting around?
Let's see. I may have, and I may have had a couple different edge slices or edge loop slices in one spot. But we got to be a little detectives here. Let's see. I'm trying to figure out what's going on. Yeah, there's a poly right there. Let's get rid of that guy. There it is. That's that's one of the problems. Let's turn on the verts for this mesh real fast, because I think I got some floating verts in there. You can always just go into your vertex selection state. Yep. Get rid of them. Yeah, that works. And now we can start bridging these together. Voila, there's the bridge. You can do multiples at the exact same time too. Oops. Let's try it again. It's me a little punk today. Yeah, okay. One of the things that's good to note when you're doing this is over in your modeling toolkit, it will tell you the number of components that you have selected. Okay, so I got one edge. I got 2 edges, okay? What about verts? Let's do some investigation. I got 1 vert selected there. Got another vert selected there. What about these guys? That one, that one. What is the problem in here? That's a good question. Yeah, absolutely, for sure. Close hole or fill hole will work just fine, or it should work just fine. Let's see if that will do it. Yep. And now let's see if good old multi-cut will give me where I want to go. Yeah, I'm not so sure, but we'll see. That, yeah, the fact that it didn't slice up that polygon is telling me there's something wrong with that vert right there. Okay, and there is still geometry in there. Let's go back in time. Yeah. Yeah. Awesome. That's fun stuff, isn't it? see, that fix it? That's looking pretty good. Yeah. There is an, oops, excuse me. There's also a hidden surface right in there. Let's see if we can figure it out. Yeah, in theory, that would work. Yeah, in theory. Yeah, merge would, let's just run that test real fast. Select all our geometry, run merge. Yep. Let's see if that solved it. Yep, that did it. That did it. Let's fill the hole, or you can just bridge it. That's maybe saved me a step. There it is. Yep. That did it. Welcome to 3D modeling. Yep. Gotta put your detective hat sometimes, right? It's a humbling experience for sure. There it is. Okay. Now the product of all this were a whole series of edges that will just increase the number of edges going around what I would like to be this circulize. Awesome. Looking pretty good. So the twist is just really super extreme. I'm a little OCD when it comes to stuff like this, but there it is. That's what I'm after. A nice circle that I then can go back in and extrude, and I'm on my way. Cool, huh? Now, one kind of change, and I want to show you this. You'll see this in a couple different spaces. So I did an extrude, okay? Now, look what direction my tool handles are showing up on the mesh itself, okay? The tool handles are following the surface normal. But if I wanted to pull these perfectly straight up and orient my tool handles to the global understanding of the XYZ axis, that's what that switch does, that little blue circle. Local, now we're in local mode. This is global. Different result, okay? Different result, okay? Even squish it down, you're on your way. I think given the context of what I'm doing, it makes sense that it be the other way around, okay? But that's a good thing to keep in mind. So circulize, it's pretty neat. There's some good stuff in there. There really is. I like using circulize. It's a fun way to very, very quickly put circular shapes into your mesh and continue marching towards what we're after. One final thing, and then I'm going to let you guys break. Symmetry, okay? Right now, my model is asymmetrical, very much asymmetrical, right? If you look, you know, I got the beginnings of an eyeball over here, okay? And I need another one of those on this side, okay? Mirroring geometry inside of Maya is a little different, okay? And I wanted to bring that to your attention so that you can start to use this as often as you can. It's going to be a central point for us going forward. I want to have the left side be identical to the right side. Right now, the right side is missing a big chunk. So I'm going to look at my scene from the front and just make sure that my camera base selection is off. And I'm going to grab all those polygons. There we go. And I'm really regretting not having done the back, but that's okay. I think given, you know what I'll do? Yeah, I'm going to delete, before I go any further, I'm going to delete all of this. There we go. That way I don't have to deal with it during the mirroring stage. Just be less confusing. Okay, once again, from the front, grab all that geo, control backspace to delete it, and now I need to mirror the geometry, okay? Before we can mirror the geometry, we need to understand how the mirror tool evaluates where we're going to mirror the geometry. And simply put, the easiest way to do this is to understand the location of the pivot point for each object, okay? So I've gone back into object mode. I apologize. I've gone back into object mode, and I'm going to run the move tool. Now look at where the tool handles show up in object mode. This represents the object's pivot point. And the mirror command is going to reference the object's pivot point as the area to duplicate the geometry. Okay? So there it is right there. I just happened to get a little lucky. I didn't move my cylinder away from the origin of the scene all that much. So the object pivot point is right where we want it to be. However, if it's not, okay, we need to move our object's pivot point. And the way that we do that here in Maya is to hit the D key, D as in delta or dog, okay? And that enters into the edit object pivot point mode, okay? And once we're in here, we can change that to wherever we want it to be, okay? Let me just kind of show you specifically what I'm talking about. So right now, I've put the pivot point for my object way off over there. See? Way off over there. If I go to the top of the screen under the mesh tools, or is it mesh? Yeah, it's under the mesh tools. Here it is. Here's mirror. If we run the mirror command, whoa, that's not fun, right? Well, there's a reason for it. We're actually mirroring it on the wrong side of the axes, okay? It's mirroring it on this side, which is completely breaking everything, okay? Let's get it to work the way we want it to work. So let's run the mirror command, but we're going to look at the mirror settings, because I think this is probably a little bit easier for us to understand, okay? We have to tell it very directly how to mirror the geometry. The mirror direction, the axis that we want to mirror it on, if we want to do it to the world, the object, the bounding box. Let's figure this out, okay? And sometimes you have to do this a couple times to make sure that we're getting what we're after. So I'm going to not do the, we don't want to mirror the negative side of the x-axis. Let's try the positive side of the x-axis and see what we get. Aha! Something kind of works, right? We also have a number of properties in here for us to evaluate. Now let's go back in, and it actually didn't honor the location of my pivot point, and it may have something to do with my transformations and some other stuff, okay? Let's go in and see what's going on. Let's do mirror axis position on object. Yeah, now it honored the location of the pivot point, okay? When it's on world, it's just going to look at the origin, okay? Now I have a gigantic little guy, right? Now, why I bring this to your attention, this pivot point idea, is it's something that we should be mindful of, okay? The pivot point inside of Maya really is a direct center representation of the mesh itself, or the object itself. So we need to be mindful of that, right? We want to make sure that our pivot point is always in the center. That way these mirroring commands and a number of other tools work the way we want it to work, right? So we can snap our pivot points wherever we want, right? Of course, the D key gets us into that mode. Okay, here we are from the front. Now, I don't want to just kind of hang out in here and move this where we want it to go. I want to do some vertex snapping. I want to snap the pivot point to an existing vert on the model itself. And to do that, hit the V key. V is in vertices, or Victor. Okay, and now it's going to snap to verts. Boom. And I have great confidence that my center point for my object is at the center of an existing piece of geometry. Okay. Okay, let's turn off the edit mode. Yep, I'm pretty happy about that. Rock and roll. And now, when I run the exact same mirror command, I'll put my, we don't have to have this on object. We can put it back to world. We'll still do on the plus side. And it's trying to merge some stuff, but fundamentally it is working. Let's put it back to object. That seemed to be giving me, maybe I am away from my origin. I may have moved it. I am. Well, not too much. Well, let's put it back to object just to make sure that I get what I want. Yep. Oh, same thing. So it could just be the weld distance. Oh, the merge threshold. Yeah. My merge threshold was too high, and it was taking verts on either side of the mesh and trying to weld them together at the merge point, excuse me. So by reducing that down to 1, I got rid of all of my problems. I think it was at 7 a second ago. So this seems to be working just fine. And now Yep, it's all one piece when I double click on it, so I know that it welded all those verts right around the border, so I'm a happy camper. If you're coming from Modo, I hope that you're starting to see that working in Maya requires going into a lot of panels, right? I think a lot of these options in Modo were right there on the surface, and they're pretty obvious. They're not on the surface here in Maya, so you got to go into the settings to change the functionality of the tool to get what you're after. And now I have a lovely little symmetrical guy. And I bet you my symmetry works now. Yep, symmetry's back. This would be an excellent time for me to delete my history on this object. Because if I go back in, I'm not going to click on it. Because look at all that. Look at all the inputs on this object, right? Yeah, you got it. I mean, look at all that input nodes, right? Not only is this, after a while, going to start to slow down the application, it's also going to create your file size, or it's going to make your file size a lot bigger, okay? Think of each one of these input nodes as data, okay? You can go from a 4 or 5 megabyte Maya project file to a 200K file size just by deleting your history. So time for me to say goodbye to all that stuff. Pop quiz. Which one of these 3 blue icons delete your history? The middle one. Yeah, the middle one. That one right there. Yes, the one with the X. Bye-bye, and we're up and running. Starting to look like a snail. Pretty cute, huh? All right, so your goal this week for your homework assignment is to block out a model of the snail. Now, we had a question earlier as to how much detail should we be putting in here. You should be able to look at your mesh and see very directly that this is a snail. I'm about 2% done on the block out of my model. There's a lot of information in here that I want to try to capture, okay? We don't want to be relying on the sub-D algorithm or just maybe even Mudbox to help us figure out and craft what that final result is going to be. So we need to be good modelers. Keep using this box modeling technique of starting with something simple, slicing and extruding and moving, scaling and rotating the vertex edges and polygons where they need to go. It's a pretty fun system. One thing on the sub-D note, Mudbox does not understand subdivision surfaces, okay? Fundamentally, it doesn't understand it, okay? So we can't use any sort of sub-D surface on our meshes in the game art pipeline. Yeah, which is both a good and a bad thing. Yep. So if we go back to your homework this week, here's what I would like you to do. Just block it out. Just making a model in Maya, okay? So this is a 100% model, Maya model, okay? And please, you have to have all quad polygons. Got to have it. No triangles across the entire mesh, okay? Try to limit the number of objects that you have in your scene itself. For mine, and you can start to see this a little bit. This is the shell, this is the base. Try to keep it down to 2 objects, okay? We don't want to have a zillion of things ended up over in Mudbox. It's going to make the sculpting experience very poor, okay? And it's going to slow down the entire experience, right? Real quick, has anyone stumbled on how to change the name of an item? Because P-cylinder 1 and P-sphere 1 really don't do a great job of describing what these things are. Does anyone figure it out? It's not, actually. Just hit the return key on your keyboard, okay? And then you can change the name of it. So this is the Snail Base, okay? And I'll do Snail Shell. That's not how you spell shell. There you go. Now notice that Maya is adding all those underscores for me, okay? Maya doesn't understand spaces in file names, so don't try to force it. It will never have a space in the file name. Or uppercase letters. Well, no, it is uppercase letters.
It does, but it can cause a problem if you export it.
Yes. Yeah.
Maybe won't read it.
Yep. There's one other thing that it doesn't support when it comes to file names. I'm trying to remember off the top of my head, but just name things. Commas, periods, and commas. I think that's what I was thinking of. Point being, name them. It's just as easy as hitting the return key. Don't make this harder than it needs to be. Maya doesn't do a really great job of describing things when we create them. It's just P-cylinder. What's the P stand for? Polygons. It's a polygonal cylinder. Polygonal sphere. Yeah.
Would it be a good practice to not use uppercase?
You certainly could. I think that's a great practice. Have a convention and just stick to it. If you want to stay all lowercase, I think that's a great idea. Some folks do this. I've seen this a lot. They'll do snail shell. This is kind of like the camel case that you see in programming often, which is just fine. I see this a lot too. They'll keep the P for polygons, and then they'll do snail shell. You see that out there in the real world often. P is always going to stand for polygon. When we'll start talking about materials here in a bit, you'll see people doing this, M, snail, shell. The M stands for material. So just have a convention, have a system, and then stick to it. Yeah.
Once you've gotten into, like, say, insert edge loop tool, is there a way to make it stop doing that? Make it what a hotkey, make it
Yes. So
go back to just regular select?
yeah, and this is welcome to Maya, man. This is both the good and the bad thing. So once a tool is on, it's on, right, until we turn it off. Yeah. So the question that Taylor had was, I'm into the insert edge loop tool, and I'm just going to reset the tool to get it back to its functionality, right? And it's on until I turn it off, right? Even if I click off the mesh, it's still on right now. And if I click on something, it's going to add a tool, right? So when you're done using a tool, here's what I would recommend that you do. Go back to your selection tool. Create the muscle memory of just hitting Q. Q is the keyboard shortcut. Q is in Quebec for the selection tool. So whenever I'm done using the tool, boom, I just hit Q real fast just to make sure that I don't accidentally, mess up my mesh with an active tool. All right. Okie dokie, let's go back to your assignment real fast. So quad polygons, that's a hard requirement for the next stage of this, okay? You have to go through, and you really need to be disciplined with your removal of triangles from your mesh. That's going to be a barrier over in Mudbox. This isn't Pat just enforcing these ideas. It's fundamentally going to stop you in your tracks over in Mudbox, okay? Another thing that I would like you to do is just to spend some time exploring this shape a little bit. Don't rush into creating the final project of this, okay? Far too often I see people just kind of jumping in and getting to final geometry without providing an opportunity for themselves to explore what it is that they're creating. Look at some reference. Actually, look at some photographs for a long, long time and be a subject matter expert on what these shapes are going to be and slowly start to establish that, okay? I think that really helps. When you're done with this assignment, please make sure that you're uploading a render and your Maya project file back to this Dropbox here on Canvas, okay? So the question was, is there kind of a relax tool that's just going to generally kind of ease out? Yeah, see you later. Maybe. Yeah. And then everything just kind of evens out. Not what she's asking, but 3, what you're doing when you hit 3 is actually enabling subdivision surfaces for this mesh. Okay, you're transforming it using the Catmull-Clark sub-D engine. Okay, hitting the 1 key on your keyboard returns it back to its polygonal cage. Okay, what Indigo was asking was if I have a whole bunch of verts all kind of collected together and I want to kind of evenly spread them out across the mesh. Let's see. Ooh, oh man, yes, there is that functionality is built in. Do I have? Yes. Okay, let's see if I can make this work real fast. Yeah, okay. So this is a total kind of go around, right? This is Pat's hack of the day. We're going to use a tool called Quad Draw. We're going to see Quad Draw again when we get to retopologizing. Quad Draw is actually meant, well, it's meant for a lot of things. It's used 90% of the time to do retopologizing because it's a way for us to very quickly snap points to our mesh, and you'll see that in the future. But one of the functionalities of Quad Draw is a smoothing algorithm. If you hold down the Shift key, see how it kind of relaxes everything? Yeah, this is in Quad Draw. Okay. Yeah, it's a fun little tool. You'll get to know Quad Draw very well. Okay, but that's a start at least. All right, so I'm going to leave it up to you and your creative devices to figure out what the render looks like. Okay, I'm not going to put too many requirements on the render because I want you to spend most of your time this week on the model itself. But it's a critical skill, this whole rendering thing. So just make sure you put a couple lights in, establish a good camera composition, and make a pretty picture of your blockout mesh of your snail when you're done. When you're finished over the next 7 days, make sure you submit the render and the Maya project file back to this assignment sheet when you're done. Sound good? Questions? Everyone's ready to rock and roll?
Stop selection is what button?
B. B as in boy. Yeah. All right, let's get to work. We've got about an hour left in class, 45 minutes or so.